All right, here we go. So it is March the, what, 20? 21st. Woohoo! All right, so my data is here and here. I'm not even sure what they mean, and I don't really care. 14, 16, 16, 17, 37, 39, 40, 40, 41, 47, 47, 49. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There they are. Okay? Abs. Cut it. Now, it looks more or less like this. Okay, I will go ahead and hit graph in a minute, I suppose, but it looks more or less like that. Yes, it's fairly linear. Am I right?
Yes.
It's fairly linear. I know it's fairly linear because, well, I made up the point so it would look fairly-ish linear. That's kind of how I did it on purpose. Now, again, the things we want to do here, we want to find R, okay? And we want to find R squared. So let's start with the Google people and the Excel people. Equals Coral, yes? And you're going to do the Y's first and then the X's. This will tell you your R, right? And then when you get the R, just square it. I mean, there's literally nothing to that, okay? Go ahead and find those. If you're on Desmos, of course, you already know what they are. If you're on your 83, 84s, it's stats, tests, linear regression, t-tests. Boom. Right? Stats, tests, stats.
I think it's frozen.
Oh, for God's sake.
I'm sorry. Just don't stop.
You hit on. There you go.
I did.
No, I'm just telling you, hit on. It's fixed it for you. Stats, tests. What's that? What'd you say?
Talk to me.
Yes.
So why do you even have
Good. Great question with the answer back here. You're going, why must we make the graph? Can you knock it off? Hey, knock it off. Josie.
We're good.
Why do we make the graph, Josie? I'll tell you why. Because if it doesn't even look remotely linear, I ain't predicting it, dog. Alright. So there it is. Boom, you're done. Okay? Now, remember, on the calculator, it's already doing this test for you, but I want to see this on your paper. Row equals, row not equals. Boom. Okay? Now, to do this, we're going to make a t-test. And so it's going to be r times n minus 2 over 1 minus r squared. This is n minus 2 degrees of freedom. All right. So, if I'm not mistaken, there were 8 data pairs here, yes? Yes? So that's 6 degrees of freedom. And what was my R? Anybody have that down?
0.96.
Boom. Oh, hey, that's pretty good. And what's R squared, just for a good
Wait,
time?
R is coral, right?
R is coral. And what's R squared then?
One's
0.94. Now notice, you are dividing by 0.06. So when you divide by 0.06, that's going to be a healthy number. Okay, so my guess is the t is going to be rather huge. And notice it's positive huge because this guy is positive. So what does it come out to be? 9.46. Now, I don't even care. Hannah, I do not even care if you find a critical value for this, for crying out loud. You get a t of 9.46, you're rejecting right now. Yes? Right now. Now, could you find it? Of course you can. Could you find a p-value for this? Of course you can. But if you get a value like this, hey, don't mess with it. Now, if I were to do a p-value for this, on our calculators, it was already given to us. Okay? Right? On your calculators, already given to you. On your 83, 84s. Okay? For those, the rest of us, on the Google Sheets and whatnot, remember, it is a t.dist, right? And what does it want to know? 9.46, is that right? And then what does it want to know?
degrees of freedom.
Degrees of freedom, which is 6. Well, for you, it's 1. For everybody else, it's a 2. That's 2 tails or something, right? For you only, Excel people, it's t.dist. It's 1 minus this, right? 1 minus this. And it's 9.46. And it's 6 degrees of freedom and 1. That's Excel. And then times that by 2, right? What do we get for a p-value? It's teeny tiny, yes? 0.0007. The long and the short of it is we're rejecting that. By rejecting that, what are we saying? There is a significant correlation here. Yes? Only at that point should a person then go, I should probably go find an equation for this. Okay? Now, 83, 84 people, you already have the equation. It's literally on your screen, as it is for the Desmos people. What is it? Read it to me. Parks, what do you got?
Y equals 1.59x plus 21.3.
Boom. Now, if I'm on the Google Sheets or if I'm on Excel, equals slope.
No, I put
Eh.
a trend line on it.
When you put a trend line on it, it shows up. So for Google Sheet people, equals slope, and then it's y's and x's. The y's and then the x's. And then equals intercept. And again, the y's and then the x's. That's Google Sheets. Listen, there's about 87 ways to do this. This is probably the easiest way in the classroom, whatever. I don't care how you get here. That's what it should come out to be. Yes?
That's all we have to find?
No. No. This is huge, people. Why do we do regression? I guarantee you this is on the next test. Why
A little better right
do we do regression? Thank you. Biggest reason, to predict for a given value of x. Okay? That's number one. That's the number one, and like number one doesn't really give it justice. Okay? It's the primary reason we do this. Number two, abs. Number two, and pretty important but not quite as important, but pretty important, to see how x changes or affects affects y, right? And in this case, if you look at it, hey, look, a change of 1 in the x direction gives you a change of 1.959 in the y direction, yes? That's it. But that comes like after. I mean, the whole deal here is I want to predict for x and y. Right? I want to predict for a new value of y. Now, watch. So my equation, as you said, was 1.59x, right? Plus what? 21.3. Okay? This is the new stuff right here. Okay? Now, what kind of values of x would I predict for? Oh, they're not on here. Hey, they're right here. Give me a number up here-ish that I might want to predict for. Well, any of the ones that are shown, right? Any of the ones that I'm missing, like 13, for instance, would be swell. 18, I wouldn't have a problem with 18 probably because it's pretty close to my data. I wouldn't have a problem with 9 or 8 probably. 27, I'm going to have a problem with predicting for 27. Yes? That's weird. Okay? But any value in here. So I'm going to try 13 just for a good time. Okay? So if I plug 13 into there, y hat 1.59 times 13 plus 21.3. What does that come out to be? I don't know, but I bet it's somewhere in the ballpark of 40-ish. What do you get? 41.27? 41.97. Beautiful. Nice. Now, that's a prediction, yes? How good of a prediction is it? Well, how do I know? Well, I don't know. So look, remember, here's our line does something like this thing or whatever. Our line kind of cuts up through the middle of this business, yes? Right? So whenever you're predicting, let's say we're here at 13, you're predicting for a value that is right, here. This is 41.97. It's right on the line. But Mr. Groom, I feel like if you just went out and found a person that had an x of 13, they probably are not going to have a 41.97, right? They might have a little bit more or a little bit less, right? And the game here is this. What we're seeing, and this is kind of a big deal, with regression, what we're going to see is this. What? It's like a normal distribution. So think about this for a minute. If you looked at all people with an x of 13, if only 13s, okay, that's it, just 13s. And if you plotted their y's, Just their, so this is only x equals 13 people. Let's say you go out and find 100 of them, okay? Now they're going to have a whole bunch of different y's, yes? Guess what their average is? 41.97. Wait a minute. If you found a whole bunch of them, how would they be distributed? Turns out in regression they are distributed, wait for it, normally. That's right. That's right. And they will have a mean that is equal to y hat of, in this case, 13. This is for the 13-year-olds. Oh my God, what would happen if it was the 14-year-olds? What would happen? Well, 14 is right here, yes? See that? And what's going to happen? Well, they have the same distribution look. Well, the same spread, but what? It would have a bigger mean, yes? So you plug 14 into that, maybe you're going to get 43. I don't know. So what would the picture look like? Well, for 14-year-olds, or whatever this is, it would look very similar, except now the average would be here at whatever this is, y of 14, whatever that is. So what is that? Plug 14 into that way. Plug 14 that way. What do you get? 43.56. Beautiful. But here's the thing. The standard deviations are the same. The standard deviations are the same. Oops, are the same. Now, here's my question. Do you know the actual mean for, let's say, x equals 13? Do you know it? No. You have an idea what it should be, yes? 41.97 or something is an approximation. What happens when you take a sample and you find a sample mean? What do we always do after that? I sampled 35 children. I found the mean was this and such. Standard deviation was that and such. What did I always do after that? Found a z-score. You're not wrong. And then I found a confidence interval. Huh? We found confidence intervals before. We will actually find confidence intervals for this 41.97. We will do plus or minus, and then there's going to be a thing out here on the end of it, right? Which is going to be our margin of error. On the next test, I will have the formula for margin of error on the board. It is gross. No one expects you to memorize it. Okay? Will it look very similar-ish to the margin of errors, or to the z-score things and stuff we did before? It'll look similar. Very similar. In other words, will there be some sort of a standard deviation thing here? Yes. Will there be some sort of t or z sort of thing here? Times it. Yes. Yes. So it'll still be there. It's just going to look a little different. So if you'll allow me, I will tell you what page it's on, and we will work through one. Fair warning, these are easy to screw up. Even if you're paying attention, they are, oh my word, easy to screw up. Because you have to end up nesting a whole bunch of parentheses inside of one another. And what happens is some dinghead always forgets one. Then they come crying because this agreement doesn't work right. Oh my God, I don't know what to do. All right, somewhere.
Is it 570?
Is it on 570?
I don't know if this is it.
That's not it. But it's on 572. My God, there it is. All right, so here it is. So I'm simply going to write it thusly. Now, your book uses y prime. I prefer y hat. Okay. Plus or minus. Oh, look, it's a t. Hey, that's cool. Who saw that coming? I did. I wonder what degree of freedom this t will be. It is n minus 2. You are amazing. Well done. Times this goofy thing. Now, when I just write s, what are you thinking? I know, but it's not quite. It's a standard error of the estimate. That's what the CEST means. I call it the CEST. The standard error of the estimate. Okay? Times this mess. Now this mess, what is this crap about, Mr. Groom? Do you remember when we used to do s over the square root of n? Do you remember that? This is basically the square root of n bit. Okay? It's not quite, but it's basically that same idea. So watch. Now this next part is kind of gross.
Oh, God.
I know, right? Now, if I was doing this, I would use these amount of parentheses that I am showing you currently. Okay?
It's gonna take me like 2 years to do one problem.
You're not wrong.
Oh, but I only put one in the test then.
No, it'll just be a 2-day test. It's going to be swell. I know, right? There it is.
This cat's hard.
It's not hard.
Oh, it's just
Again, how do you eat an elephant?
this looks like my grandma.
One bite at a time. Now, you simply... Do you know what 1 is? I feel like I do. Do you feel like you know what n is? Yeah. Do you know what n is?
Yeah.
Yeah. Do you know what this x here is? I'll tell you what this x is. This is the one you're predicting for. So in this case, 13. Hey, x bar, I know what x bar is. It's the average of the x's. Do I know what it is? Kinda. But if I didn't, I could find it, yes? Oh my gosh, on the bottom, it's the sum of the x squareds. See, maybe square these x's and then add them together. Hey, this is the sum of the x's, and then when you're done, square them. Oh. So I literally know all of this crap. It's just a matter of dealing with it. Okay? So, if you allow... One thing at a time, dear. Okay, what do you got?
And I want to ask.
What's your question?
The
The CEST. Were you going to ask me where to find it?
yeah.
I was literally going to tell you people how to do it. So on your TI 8384s, let me pop mine open so I can just show you real quick, all right? Listen, one thing at a time, yo. So stats test, you've already done this. This thing pops up. Whatever. Shh. If you scroll through this mess, down here toward the bottom a ways, you see that S right there? 6.5? Yo, that's the, well, it's not 6.5 for you, but for me it is. This is an old problem. That's the CEST. Oh my gosh, it's right there.
Wait, is the S?
It's the CEST. That S right there. The S that's under the linear regression t-test is the CEST.
Sounds like 6.
Okay? Now, wait. 83, 84 people. Listen to me. Go in and go stats, calc, 1var stats, you see? On list 1. Because those are my x's. And look what it spits out at you. Shut up. It gives you x bar, the sum of the x's, and the sum of the x squareds. Boom, boom, and a boom. Okay? That's it. It is not hard. It's right there. This is where the 83, 84, I think, well, and the 89s have it over some of the rest of you because it's kind of like 2 buttons, boom, there's everything you need to know. All right. Now you people sit tight for a minute. If I was on my Google Sheets / my Excel and I had data like this, actually I'm just going to do it in Excel because why not? Oh, then you pushed the wrong button. God, you're dumb. All right, try it again. Here we go. Come on. Atta babe. Whee! Let me put my data in just for a good time. So 10, 11.
14, 16, 16, 17. Oh, 37, 39, 40, 40, 41, 47, 47, 49.
Okay, Q. Hey, what I would like to know is what is this? Okay, I need several things. I need the average, yes? So equals average of my x's, yes? So you can type it in or you can click and drag it. I don't know if you can click and drag on your Google Sheets, but you get the gist of it, right? You know how to average things. Boom, done.
Are you doing that in this?
I need it for that formula. I need x bar, don't I? So there it is. There's my x bar. Okay? What else do I need? I need the sum of the x's, yes? So let me get that. And again, it can be put anywhere you want. Equals sum of, well, A1 to like A8, yes? That's the sum of the x's. Boom. What?
That's what sigma means.
Sigma means add them up. That's literally all it means. And it also wants to know what? It wants to know the sum of the x squares. Yes? Well, how would I get the x squareds? I feel like I would just go x squared, wouldn't you?
Oh.
It's not hard, right? Yes or no?
Square them all at one time. Why?
Because the formula wants the sum of the x squareds.
So when you square 107?
107? No! You, lady, are ahead of the game. Come over here. Look at it. Look, look, look. 107 is this fella. And then I'm going to square it later. You see that? But this is the x squareds come first, and then I add. Why, Mr. Groom? Because please excuse my dear Aunt Sally. It says I should exponentize before I add, yes? Exponents, please excuse my dear Aunt Sally. But why do this one different? Because parentheses, yo. It says add first and then square, yes? See? All right, let's do it. We got to find them both. No particular order. Hit enter. And then I can just drag these guys down. Whee! Which, again, is trickier said than done. Trickier said than done on a phone, I am guessing, for filling. But a person could just go equals this squared equals that squared. If it was Mr. Groom, I'd go, well, 10 squared is 100, and then I'd just do 121, 144. I'd probably just type them in because I'm lazy like that. Okay? Because I could probably type it in faster, and I could do equals this squared if I can't drag. But if I can drag, I'm just going to drag. Okay? Hey, wait, I need the sum of this column, yes? So equals sum of this column. Oops. Try again, dummy. There we go. Whee! All right. Seriously? Are you effing kidding me? Awesome. Yay! What just happened? My keyboard hates me. What do you know about that? Huh. Oh, now you're going to work. It hates me, Miss Cox. It hates me. There it is. Okay. Now, 83, 84 people. Do you agree with me? Do you have the same numbers? Yes. Okay. Now, this is a nasty process, friends. It's not pretty. It's not. Anybody that tells you that this is a fun deal is a liar. They are horrible people. So 41.97 goes right here. Plus or minus. Now, let's leave this piece alone for just a moment. Okay, we'll leave it alone for just a moment. Let's do this square root garbage first, okay? So that's 1 plus 1 over 8 plus, I'm going to do 8 times 13, because that's who I'm predicting for, minus, what's my average? We just found it. Was it 075? Oh, 375. Beautiful. Thank you. Squared divided by parentheses 8. Now, what is the sum of the x squareds? We just did it. I don't know. 1483, right? Minus 107 squared. Ta-da! Now, try this on your calculator. And I'll do it on mine, and we'll see if we agree.
We were not having tea.
Well, we'll do the T and the cest in a minute, one thing at a time. Listen, the T and the cest is the easiest part of the whole freaking process, yo. All right? If you can't just go look up a T and look up the cest, you've got issues, okay? But this mess here is the hardest part of the whole process, by far. It's not even close. I mean, it's not even close. So, I normally... Oh, shoot. What are you doing? Stop. I normally just go ahead and do the inside first when I'm using one of these calculators, only because if I don't, I feel like I'm going to screw something up. So I will just square root whatever I get for an answer when I'm done. I got 1.06. Yes! Cox agrees with me. This is exciting. All right. 1.06. Woo! Nice. Okay. Okay. That cool? All right. Okay. Whew. Okay. Okay. We good? All right. Now. All right. Let's try this thing now. Mr. Groom, how do I find the zest, if you will, on a spreadsheet? So equals STD, as always. Now, I will tell you, it's one of those. Now, let's see here. I've got standardized. Well, that's not it, obviously. So I'll just put D there. P is population. It literally says that, based on the population. That's based on a sample. That's not what I want. Based on a sample, logic, no. Oh, no. Population, no. No. Wait, where did it go? Standard D. Oh, no. What happened? Went too far. There it is. It's this one right there. The standard error of the predicted value for Y for each S. It's the STEYX. STEYX. That's the zest. So, boom. Boom. The sticks, I guess. Now look what it wants. It wants the Y's, and then it wants the X's. Oh, it's 1.2. Okay? 1.2. Now, hang on. Something's a little screwy there. Oh, wait, what did you guys get for yours? Is that what you guys for yours? On that? In my mind, I was thinking 6, because mine said 6, but mine was wrong. Oh, it's freaking me out. I'm like, no! So, it should be, remember, what did I say it was? 1.21? Okay? That is not very hard.
No.
And now all I need is the T, yes? How do I find that T? You literally told me, Mr. Groom, it's probably n minus 2 degrees of freedom, which means it's 6 degrees of freedom. What kind of confidence interval are we making, yo? You tell me. I don't know. I just work here. You want 90? You want 95? What do you want?
95.
95. I heard the loudest person. I don't know if that was the first person or the whatever. Emily was the loudest that time. So I'm going to go 0.025. Yes? I'm just teasing with you. So T inverse, right, of 0.025 comma 6. That's what I'm looking for, correct? We know how to do this garbage. What does that come out to be? Come on. For God's sakes, what are you waiting for? Do it on your calculator. Let's go. What is it? It's negative point something, negative 1 point or something, or 2 point something. What is it? What is it?
Negative 2.45.
Thank you. So I'm just going to put 2.45 right here. Why not negative? Because it's plus or minus, yo. So listen, friends, this whole thing right here, this whole thing is the margin of error. The whole thing. So if someone would kindly type all that mess into your calculator and give me a margin of error, that'd be swell. So 2.4 times 1.2 times 1.06. Mr. Groom, I feel like if I had predicted for a different value, this would be different. You're not wrong. By the way, this would also be a little different, yes? Because I would have used 14 or 15 or something in that prediction value, yes? Okay. What'd you get? What'd you get? Say it. No, you added. Don't add it. I just want the 4 point something. Is that what you got? 4 point something? 3.14? Well, it's pi. So 41.97 plus or minus pi. How exciting. How weird is that? Anyway, clearly if you add it and subtract it, we'll get our confidence interval, yes? And so what is that? 40, what'd you say, 45?
45.11.
On the top end. And on the bottom end?
38.8.
Ta-da!
8.
Ta-da! Nice. It's not hard. It's a little tedious, but it's not hard. It's not hard. Well, listen. Okay, can I just say this morning, a certain kid who came into my room this morning, he comes in my room first grade every morning. No, but he was there when it happened. And no, not someone like that. And life is so boring and and this and that, and I just don't want to do anything. And that, bro, your whole life will be filled up with a lot of just that sort. You end up taking out the figurative trash in your life and cleaning the figurative toilets in your life more than you do, I don't know, standing on the mountainside looking at the beautiful horizon on a beautiful crisp morning in your life. You'll find there's more of the cleaning the toilet moments, so to speak, that you don't want to do. Well, get over it. All right? And then you can enjoy even more the days off when you're looking at the beautiful horizon. Okay? Let's do another. All right? Now, we can speed this sucker up. What's the question, dear? What?
So that,
You guys start typing this one in while she's talking. Go ahead. I'm going to catch up with you in a minute. Go ahead.
like 3 steps before we got the answer.
Sure.
We have 1.21 in the equation.
Yes. That's the SEST.
How do we find
Dear, on your Google Sheets, you will do STEYX of the Y's. So highlight the Y's and then comma highlight the X's. Boom. That's the SEST. STE, standard error, and then the Y's and X's mean of the regression of the SEST means standard error of the estimate. Okay? But that's how it is in the Google Sheets and so forth. All right, and here are some numbers to go with. I'm just making this up. I don't know. I think those look fairly-ish in a straight line. I want to bring up my Excel and make it smaller so I can type it in. Get over here, you dumb hippie. And after a while, it's not horrible. But again, no one says you have to like it. You just got to do it. Or don't, by the way. It's your grade. I don't care. Anyway, I just yell at the kid because he's a senior. And I'm like, dude, you're an idiot. Because, okay, you're going to graduate like in 2 months. Just suck it up and deal with it, yo. Oh, but it's so boring. Oh, ugh.
I'm so sick. I want to know who it was.
Well, Hawkins knows. Oh, no. What happened?
You put 156. Okay.
Oh, how did this happen? Go back. Oh, no. How about you click on the right deal, stupid? How about you click on that? What did I put? Oops.
Oh, 100.
What was it supposed to be? 15?
16.
Oh, 16.
Oh, I don't know.
There we go. I bet it works this time. No, there we go. Oh! Praise the Lord. Look at that. Huh? All right. So the rest of you, again, you've typed it in, Abs. You want to find a graph, you simply hit zoom 9 on your 8384. And then write that picture down. Now, then go and find r and r squared and y equals mx plus b. Try it on your machine. This is what it should be. Your equation should be that, and your r squared should be that. If I wanted r, I'm just going to square root it on this dealy bob, yes? So try it, see what you get.
It's probably really simple, but it's not letting me like put anything or put data into the table. So like,
Because you're clear up on top. You can't be up there. You got to be down there. You can't be on top of the list one. You have to be in the list. What?
Can I ask you a question? I thought you getting mad at me.
No?
Okay, well, I wasn't here like when we learned how to like figure out to get words
Yo.
to get the Y's.
Linear regression. Why are you sorry?
Because I feel like you get mad at me.
I'm not mad at you. It's literally everything is right there, Ben.
I can't be mean, guys.
Okay. Mr. Groom is not mean.
I think it's not me. Probably.
I don't like you.
When I have a question.
I'm not mad. Listen, everybody in the room, raise your hand if you do not have a smartphone. Wow. And yet Mr. Groom can run a freaking technology program. multiples of them, and he still drives a stupid smartphone, a flip phone. So, friends, listen. Once you get the hang of something on this game or that game, and the swipey this way and a that way, and a woohoo and a this and a that, and a shake it just right, I don't really want to hear a whole lot of, you know what I'm saying? I feel like most of us can run technology better than I can. Okay? I'm just saying. Okay? So I'll help you. I'm not mad. It's like I feel like a lot of us we can just do it. We can do it. Okay? Like this right here. You do it on a calculator and you do your story at the same time. It's exciting. You all written down? Shh. All right. So my r squared is 0.83. I should probably find my r. So my r is the square root of 0.8303, which is, oh, you piece of crap. Well, I'm going to do it myself. 0.91. Okay. All right. So there it is. So I'm going to write some of this stuff down. First of all, I got an r of 0.91. I got an r squared of 0.83. That's cool. I know that my regression that I need to test, my correlation rather, is this and this. I know that my t-score is going to be r, oops, wrong one, dummy, 0.91, square root of something over 1 minus 0.8303. And there are 9 pairs, so 7. And I feel like that's going to be a pretty big number. What is it? Holy cow. Listen, if you get a T of 5.5, what are you doing? Rejecting the bejesus out of this thing. By rejecting H naught, what are we saying? Reject H naught. There is a significant correlation. And of course, what does that mean? It means to me I can keep going. What?
Okay. How did you know you rejected? Because
Holy buckets. Look at this thing. Here's T. What is any cutoff score we've ever had? It's 2-ish. Negative 2-ish. Right? Now, if this score had been like 2.1, then I'm going to go find a cutoff score, yes? Or find a p-value for it. It's 5, boom, done. We're done right now. 7, oh, for God's sakes, you're done. Okay? If it's 0.2, you don't got to look up one for that either. If you get a t-value of 0.2, you fail to reject, right? I mean, every time. 2-ish is the magic number, right? So if it's around 2, you should go check. If it's not around 2, hey, we're done. And 83, 84 people, it's literally on the stats, that it has a p-value on that stats test t-test, doesn't it? What is the p-value for that? 0.0006 or something, which is clearly less than any 0.05 or 0.1 or anything we'd ever ask you about, yes? That's nice. All right, so is y hat equals, what was it? 1.26 or something? What was it? Plus 5.47. Okay, again, we all should have that down for us, yes? All right. And then over here, I want to predict for...
Are you just like tell us what number to predict for or something?
I want to predict for 11 because I feel like it. Okay? I'm going to predict for 11. So here we go. So y hat of 11, 1.26 times 11. What does that come out to be? I know you can. 19.33? Beautiful. Nice. 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 So let's look at this. Remember, this function is basically like an x bar, doesn't it, when we were doing regular old confidence intervals, yes? That's going to be the center of our prediction, and we're going to go out from there. So it's going to be 19.33 plus or minus. Remember, it's going to be t times the cest times that nasty mess, 1 plus 1 over n. Let's see if I can do it from memory. N x minus x bar squared over n sum of the x squareds minus the sum of the x's squared. Did I do it right? Did I do it right? Yay! Yay me! All right. So let's do this. So 1 plus, there's 9 of them, is that right? Is there 9? 1 over 9 plus 9. Now we're predicting for 11, correct? That's what we're predicting for?
Yes.
But Mr. Groom, we don't know what our...
Let's make it 95.
Well, yeah, no, we haven't got that yet. But let's go find our numbers. We need X bar. So down here somewhere, I'm just going to say equals average. The rest of us on our 89s are just going to go stats, calc, 1 bar stats, yes? 83s, and so forth. But the rest of us will do it this way. So there's my average, right? Oh, yeah, I want the sum of the x's as well. So the sum of the x's are that guy. And then I need the x's squared. And again, this one's pretty easy. So if you ask me to do this on my little phone, I go 49, 64, 64, 81, 81, 100, 100, 144, 169. Okay? But on here, I'm just going to frickin' click and drag them. Frickin' click and drag them. That sounded funny. Okay, there we go. Cha-ching. All right. Equals sum. Whee! Boom.
Okay. So annoying, can't figure it out.
Listen, I don't know how to do it on your phone,
I
but
know, I'm just saying.
but it, you know, I don't know. I don't know. It's not really that hard, though. I don't think so. Listen, I'm never going to give you that many. If I wanted you to predict for a zillion of them, we go into Excel and do it in Excel right now. Okay, I mean, right now we do it in Excel. But yeah. All right, so here's all the pieces we need. So it's going to be 11 minus 9.555, yes? Right? Over. And what goes on the bottom? It's going to be 9 times, now what did I say the sum of the x squareds was? 852. Minus the sum of the x's was 86 squared. Like that, right? Let me get my calculator out and mess with that. Well, no, I want to see if I can do it. Don't ruin it for me. Oh my gosh. $1.088? Yes! Excellent. You who said this was so hard and I don't want to do it?
I said I just don't know how to.
No, I'm just giving you crap. It's okay. So remember, for the t, we're going to go t inverse or whatever, t inverse, t dot inverse, however you do it. This is if this is a 95% confidence interval again, 0.025 comma, how many degrees of freedom? 7. And what does it come out to be?
2.36.
2.36. Of course, it's negative, but drop the negative. Nobody cares, right? Because we're doing plus and minus. Yes, dear. Okay. Now, remember, the CEST. We find the CEST on our 83, 84s. It's in the regression t-test business, yes? But for the rest of us, we're going to do the sticks. So equals STEYX. Boom. Y's, comma, X. Oh, shoot. What did I just do? No, okay, we're good. What now?
Why does it want Y's first?
That's just how it's been programmed. But in general, whenever we do regression, we start with what the response variable is. That's the y's, and then we build our factors come afterwards, our x's. That's just how it's always been done. But it has to do with when they program it. So 1.18, 1.1. Uh-oh. Ah! I have a magic pen. How exciting. It's not exciting. What? Oh, for crying out loud. Now you're going to work. What is this garbage? There we go. Okay, cool, whatever. There it is. So crunch out this guy for me, my margin of error. 3.06, I'm told. If you disagree with her, you're not disagreeing with me, you're disagreeing with Josie, and I'm okay with that. 22.39 on the top end, yes? And on the other end, it's going to be 16.27. Is that right? And we're 95% confident that what is in there? The true what? The true, not the true mean, not the true correlation. That doesn't even make sense. I don't know what that means. The true y for a value of what? For an x value of 11. Yes, that's right. So when x is 11, right? You could think of it as a true mean, right? But for 11-year-olds, or 11, whatever x is 11. Okay? That's it. Now, yes, listen, but here's the thing. When you go do your homework tonight, you can do all the sections 1, 2, and 3. Now, if you have not started yet, Hainsey, if it was Mr. Groom, I would look like on the section 1 and look at like problem number 3. Mark has da-da-da-da-da, and here's some stuff. Well, that's cool. In section 1, it asks if the correlation is significant or not. That's Q. I flip over to the next section, like, oh, it says find a regression equation. Oh, okay, Q. For the same problem, literally. Flip over to the next one. Oh, predict for when x is 12. Shut up. So if you're smart, you'll kind of keep an eye on that. Now, I'm 99. No, that's not true. Dementia kicking in. I'm 90% confident that I tweaked the homework last year so that you're doing the same ones on every page. So I think that when I got the new book that it wasn't, and I think I tweaked it, but I do have dementia. I'm going to go back to 85% confident. But anyways, whatever. So just be aware of that. A person might think ahead when they start the homework, because if it's going to ask you to do it later, you might as well do it at the same time. Okay? Really wasn't that horrible, was it? No. No, it wasn't.